Okay, very good day to everyone. My name is Nimaraj, son of Rajendran. Today, I would like to explain about the parameters of the three-phase system. So, for the introduction, in three-phase system, the three phases can be connected in either star or delta configurations. Windings of a three-phase transformer can be connected in various configurations, such as star to star, star to delta, and delta to star. For our case, our project is based on the connection of winding about star and star, alright, which is the source and the load, both are connected in star configurations. Okay, the primary winding, each phase is 120-degree electrical out of phase with other two phases. Okay, I just would like to explain about that. Let's say we just neglect the value of power source. I'm just want to talk about the phase around here, which means the let's say the source around here, sorry, the phase around here is 0. Here it would be negative 120, and here it would be positive 120. That's what meant around here. Okay, I think I made the things clear on here. And then okay, the connection of primary neutral to the neutral of generator as an added advantage. Okay, this is also one of the important point, which is I'm going to talk about the neutral point. So the neutral point around here, we can either connect the neutral, both the neutral to one single line, or else we either not need to be connected at all. It's actually depends on the system itself. Okay. In our case, we connected the neutral of both and then grounded it. Okay. In this experiment, sorry, in this project, one of the main things that we done here is the measurement of the three phase power active power, three phase active power. Okay, which is we use two different methods, which is conventional and also 2 watt meter method. I will explain in detail about the both type of measurements in detail in a while. All right. Okay, this is an example of the diagram, which is a 2 watt meter method diagram, where this one considers the 1 meter 1 and this one is considered as 1 meter 2. Okay, in the calculation I will show in detail about how we able to acquire the value of the value of the power 1 and value of the power 2, and then we total up both, then we get the total active power. All right, I'll get to that in a while. So regarding to our objective, okay, our objective, okay, the primary objective is to evaluate the parameters of the electrical system in the context of transmission and load impedance, currents, voltages, and acceptable voltage drop based on BS7671 or any malicious authority standard. Second one, evaluate and analyze the active power absorbed by the loads by using 2 watt meter method and the conventional measuring method. I got explained about this earlier. And then the last one is justify the normal operating condition of the electrical system and validate the study with simulations. All right. At the conclusion, I will analyze all these things and then I am going to explain about that in detail. So methodology. Okay, the flowchart. It's more to about how I did this project, the procedures and the techniques that I have been used to complete this project. Okay, first of all, understanding about the title and the objective of the project is very important because based on this, we will try to see how. I mean, we will try to analyze and searching the things that needed for our project. Okay. Okay, first of all, okay, the values of the rated line voltage, transmission loss, and load impedance are identified. Okay, these are the voltages. All these are based on our metric number because different students are given different matrix number. Sorry, different values. Okay, here all the values of parameters such as transmission loss, load voltage, line current, phase voltage, and power absorbed by the load in both conventional 2 watt method has been calculated manually. And then the values of okay, we also have been given the inductive value which is in ohms, so I have to convert that in Henry so that we can insert the values in the power simulator. And then we have to construct our star to star connection in the P simulator, and then we have to use the necessary meters to evaluate the values such as the voltage, currents, and power. After that, we also have to manually calculate the values, and then we use the value to compare with the measure values. Okay, I've got a table around there. Later on, I'll be explained. Okay, this is just the explanation that I've done just now. Okay, just in verbal. That's all. And then okay, the waveform part. Okay, this is also one of the important component where I got things that we measure and things that we calculate manually will be what we call that, we can justify the values by using the waveforms. Okay. Okay, based on the calculations, okay, this is how I calculate the values all. First of all, they give us the 275 kilovolt line voltage. So using that line voltage, we have to find the phase voltage. This is the formula used to find the phase voltage. Okay. So once we find the phase voltage, we have to put the phases, which is I got mentioned earlier, which is 0 degree, negative 120 degree, and 120 degree. Okay, these are one of the important component. All right, and then the transmission load parameters conversion. Okay, as I told you guys earlier, these things have to be converted to its default value, which is Henry. Okay, because these things are in ohm. We cannot insert the things in ohm using in the power simulator software. And then line current, okay, the line current is equals to phase current in start to start connection. So I think doesn't matter, doesn't have issue at all. So here, line current. How to find the line current? Okay, this is a formula which is using the phase voltage divided with the Z line, which means the transmission loss and the load. All right. So here we got the transmission loss and the load around here. So you have to combine both and then divide it with the phase voltage. All right, we'll get the values. And then transmission loss. Okay, this one is the voltage, specifically the voltage around here. We have been calculated using the impedance multiply with the current that flow through here. Okay, the current will flow through here, all the same only. All right. Here, this is the load voltage, same as the transmission loss. Here we will calculate the voltage around the load by multiplying the current that passes through around here. Okay, okay, that's all. For power calculation method, okay, we got two methods as I mentioned just now, which is a conventional way of measuring the power and also 2 wattmeter method. The conventional method is quite easy, which is we just have to use the formula something like this. Okay, 3 VI cos theta, which means the voltage you have to use the 3 times with the voltage times with current, and then you have to use the cos, and then the theta here is a you have to use the what we call that voltage of any degrees around here. Okay, any voltages around the load. All right, I mean sorry, the degree around any voltages. Let's say you have been choosing VAN, and then you have to for the current part you have to choose the same IAA, which means the same line I mentioned. What I mean is it should be the same line. So 1.44k, and then okay, this one the degree 7. This one is representing the voltage, and this one you have to minus with the current one. Okay, because the minus it become plus. So 13.34 as you can see around here, 13.34. All right. So this is how we acquire our calculation by conventional method. Here the power calculation for 2 wattmeter method. The 2 wattmeter method looks a bit complex, but it's not at all. So we have to acquire the P1 by using some formulas. Okay, this is also the same. You have to use the same line, and then just have to add the 30 degree at the behind, which means because it's in the we have to convert the power. The power calculation has been made in the line formula. That's why we have to include the 30 degree. All right. Then P1 and then the P2 the same way we have to do 30 degree you have to include, and then once we get the values we have to total up both the values so that we can get the total power. Okay, this is about the voltage drop percentage around here, which means this is the formula we have to use. V supply minus with V load divide with V supply again, and then multiply with 100. So we get the voltage drop percentage around here, which is 34.09%. All right. Okay, this is the results. Okay, okay, as I mentioned you guys earlier, which is the simulation, these waveforms are important so that we can compare our answers which we acquire by the measure by the calculation method. Okay, let's say here just a simple method. Okay, this one all we have to we get it from the simulator itself. Okay, as you can see around here, these voltages all are same. Okay, VLAN V2 with okay, I just want to check this one all, but in different phases. Okay, that's why you can see all the values, the peak values all are same, but it's not in the same phase because as I told you guys earlier, it's 0, 120, positive, negative 120 and positive 120. That's the reason. All right, it applies for everything. As we can see around here, the values will be same, but the phases will be different. For the transmission loss, it's same. The values will be same, but the phases will be different. Okay. Okay. This is the table of calculated and measure value around here. Okay. We have been compare both the calculated and measure value. Okay. Now as we can see around here, both the values are similar. I mean almost similar with just the slightest difference at the back. we can neglect that thing as long as the first 3 to 4 decimal places are accurate. Okay, this one no need to get confused because this one is in ampere and this one is in kilo ampere. That's why here got 1 point something, here no need, don't have. All right, and then we going for the discussion. All right, okay, the discussion is about what we get in this in this project. Okay, in this three-phase system, both the generator and load connected in star. As the theory explained for the star connection, the line voltage will be Z3 of phase voltage. Given the generated line voltage for the design of the system is 275 kilovolt. As I mentioned earlier, the line voltage have been provided is 275 kilovolt. Okay, and then we have to convert the line voltage to the phase voltage so that then only we can able to do the calculations. All right. Since both the generator and the load is connected in star connection, it's easy to use phase voltage. Okay, the phase voltage for calculations of load voltage, transmission loss, phase and line currents, and also power absorbed by the load. Okay, so important thing. And then the line current in the star connection is same as the phase current, which is IL equals to IP. I've been shown in the earlier version. The calculation for line current obtained by dividing the phase voltage with the load and transmission loss impedance. Okay, phase angle of 0, negative 120 and 120 has been used because it is a positive cycle. Okay, let's say it's a negative cycle, means the values will be vice versa, which is 0, 120 first, and then only negative 120 will become. All right. Okay, this is the this is the diagram which we construct the circuit in power simulator. All right, where I've been shown that how I calculate the current using the ammeter which is connected in series, and also how I calculate my voltages around the transmission loss, around the transmission, around the load, or by connecting the voltage source around here and here, something like that. Okay, for the V line, we have to have been placed the voltmeter by having the knob around. Let's say this one is A, this one is B, so A B. Here let's say it's a B and C. This one will be calculated from C to A. This one I guess you guys can see this dot around here is indicating that the positive supply around here, sorry, the positive knob. All right, and then you have been grounded all the values I've been showing. All right. Well, we can see about the okay, for the power calculation of power absorbed by the load, two different methods has been used as I mentioned earlier, which is conventional and two wattmeter method. Okay, so two wattmeter uses some complex calculations to obtain the overall power absorbed by the load. Two different power absorbed value in what will we get, which is labeled P1 and P2. Okay, once we adding the P1 and P2 method, then we will get the total power absorbed by the load, which is the active power we are discussing around here. All right. Okay, as our conclusion, from this investigation, all the values of current, load voltage, transmission loss, and power absorbed by the load has determined and evaluated by both calculation and simulation. Furthermore, successfully has been evaluated the parameters of the electrical system in the context of transmission. Okay, this is what I mentioned. What I mentioned on here is the object. I'm just want to tell that all the objective that we have been mentioned earlier has been succeeded. Okay, we succeed with all the objectives. Okay, evaluate and analyze the active power absorbed by the loads by using two wattmeter method and the conventional measuring method. And finally, the start to start system also had been justified under the normal operating condition of the electrical system and validated the study with simulation. Okay, these are some references that have been used. Okay, all the references are from internet itself because we don't really have any access for the books which are in let's say in university means we can access for the library for the books since the MCO period. All the information we have been gathered using the online. All right. Okay, I guess I'll cover all the stuff around here. All right, the waveforms, the transmission laws, the methodology. All right. Okay, this is what our project about. All right. Okay, thank you, sir.